Morning friends, welcome back to my video. So today's topic is to connect two roll sections by providing splice plates when the connection is facing a compression force, right? So question is, a column section ISHB 300 at the rate 600/118 Newton per meter is to be spliced. What does it means that is to be spliced? Is to be spliced mean that we have to provide a splice plate to connect two compression member. For example, I want to show this in the diagram. This diagram is depicting that there are two I sections. This one is the flange and these are the flange and this one is web. So these two I sections are connecting with each other by help of splice plates. Two splice plates are provided here, right? You can see in the diagram. So these outer splice plates are connecting the flanges, right? And this in between splice plate, which is a shear splice plate, is connecting webs of the I section. Therefore, splice plates are the plates which helps us to provide the connection, which helps us to provide a joint between roll sections or any plates, right? So get back to the question. Axial load over the column is given as 450 kN, shear force 100 kN, bending moment 30 kN meter. Design the splice plates and bolted connections using bolts of grade 4.6, assume steel grade Fe 410, right? So as per this data, for steel of grade 410, the ultimate stress is going to be 410 MPa and yield stress is going to be 250 MPa. Similarly, the bolts of grade 4.6, the ultimate stress for bolt is going to be 400 MPa, right? So there's an important note, guys, which says when column ends to be machined means there is no error to provide connection and perfectly placed one over other. For complete bearing, then 50% of the load is transferred directly and remaining 50% by fasteners, which means the roll section is only taking the 50% load and rest load is taken by the fasteners. If roll section is taking only the 50% load, therefore total load is going to be divided by 2. Total load divided by 2, which is 450 divided by 2 is equal to 225 kilonewton, right? Further, because two splice plates are to be provided on both sides, as we can see in this diagram, that one splice plate to connect these flanges and other splice plates to be connect these flanges are there. Therefore, because two splice plates are to be provided on both sides, therefore direct load on each splice plate is also going to be divided by 2. So 450 divided by 2 is equal to 225 and 225 divided by 2 is equal to 112 kilonewton, right? So direct load on splice plate is 112.5 kilonewton. Now, load on splice due to moment. This is total moment divided by lever arm distance. See, total moment is given already in the question itself, 30 kilonewton meter. So 10 raised to power 6, because we want to convert kilonewton into Newton and meter into mm, right? And from where this 300 plus 6 came. So here we are assuming that the thickness of the splice plate is 6 mm. Therefore, if the thickness of the splice plate is 6 mm and depth of the section is 300, therefore from this point plus the thickness of the splice plate, it is total it is going to be 300 plus 6, which is 306. Therefore, the load on splice due to moment is 13 to 10 raised to power 6 divided by 300 plus 6, right? Which is coming as 90 kilonewton. So direct load 112.5, load due to moment 90 kilonewton. Therefore, the total load is going to be, here 98 kilonewton will come, right? I will correct the mistake. Okay. So 112.5 plus 98, which is 210.5, right? Kilonewton. This is a total design load taken by the splice. So now guys, we have to provide the dimension to the splice. it is pretty obvious that the splice width is going to be 250 because the width of the flange is also 250. The value of 250 we have taken from the steel table, right? So because width of flange is 250, therefore the width of splice plate is also going to be 250 mm, right? Now the next task is to find out thickness of the splice plate. So guys, how to find thickness of the splice plate? I'm using very basic formula, which is stress is equal to load upon area. Stress is Fy, load is P, area is width into thickness. Width and thickness of the plate, right? Therefore Fy is equal to P upon B into T. Therefore T is equal to P divided by B into Fy. P is load, which is total load due to movement plus load due to direct load, right? Which is 210.5 into 10 raised to power 3, because I want to convert kilonewton into Newton. Divide by width of the flange, width of the splice, which is 250, multiply by Fy value, which is 250, right? So answer is coming that we need at least the thickness of 3.368 mm, whereas we are providing the thickness of 6 mm. Therefore, the thickness which we have provided is sufficient. Therefore, width is 250 mm, which we have decided so far, and thickness is 6 mm. Now, the last dimension to find is length of the splice. But it is pretty obvious that length of the splice depends upon the bolts provided in the row. So first of all, in order to know the length of the splice, first we need to know that how many bolts we have to provide in the row, right? So let us assume that we are providing the diameter of the bolt as 20 mm, right? So if dia of the bolt is 20 mm, therefore dia hole is going to be 20 plus clearance distance, which is 2 mm, therefore 22 mm. Now we will find the strength of the bolt and single shear, right? Strength of the bolt and single shear formula is ASP multiplied by FUB divided by under root gamma MB, partial safety factor. Guys, this formula is given in IS code, IS 800-2007, clause 10.3.3, page number 75, right? ASB is 0.78 into pi by 4 d square. FUB is ultimate strength, ultimate stress of bolt, right? Under root 3 partial safety factor into 10 raised to power 3, because we want to Newton into kilonewton. Therefore, answer is coming as 45.26 kilonewton. Now, we have to find strength of bolt and bearing. So, the formula is 2.5 kb into D into T into Fu divided by gamma MB. This formula is given on clause 10.3.4, page number 75, IS 800-2007, right? So, 2.5 kb is not given. Therefore, we are assuming as 1. Dia of the bolt 20, thickness of the bolt, thickness of the splice plate 6 mm, which we have assumed. Fu 400 divided by partial safety factor into 10 raised to power minus 3, because I want to convert Newton into kilonewton. Therefore, bearing of the bolt is coming as 90 kilonewton. Guys, we know that the strength is always considered as least of shear and bear. So least is coming 45.26, which means the strength of 20 mm dia bolt is 45.26, right? So by getting this value, we can find number of bolts. How? So number of bolt is going to be total load divided by load taken by one bolt, right? Total load is 225 taken by the splice plates, and this is strength of bolt of one bolt, right? So this divided by this value is coming 4.97. Let us given an even value. So approximately we will provide 6 number of bolts, right? So same has been depicted in the diagram. This is a front view, this is a side view, this is a flange, this is a splice plate. So between flange and splice plates, 1, 2, 3, 4, 5, 6 bolts in a row has been provided, right? So now we have to assume pitch and edge. Let us assume that pitch of 60 mm has been provided and edge of 40 mm has been provided. So guys, there are in between 6 bolts, there are going to be 5 pitches and 1 and 2 edge distance. Therefore, 5 into pitch distance plus 2 into edge distance, which is equal to 380 kilonewton. So this, 380 mm. So this is the value of the length which we will provide. Therefore, the splice plate is having dimension of length 380 mm, width 250 mm, thickness 6 mm, right? So that's all. We have designed the connection of compression members, right? One splice plate here, one other splice plate here. This we have designed. We have found the number of poles. We have found the volume, which means width, thickness, length of both splice plates. In next video, we will learn that how to design this shear splice plates, right? So if you have any doubt in my video, you can comment below, right? I will feel very happy to clear your all doubts. Thank you for watching this. Have a good day.